This is pre-algebra lesson 4-3, prime factorization and greatest common factor, otherwise known as GCF. A prime number is an integer greater than 1 with only two factors, 1 and itself. A good example of a prime number, 3 is a prime number, because the only way you can get 3 is 1 times 3. So it's a prime number. A composite number is an integer greater than 1 with more than two positive factors. 12 would be a good example of a composite number because its factors are 1, 2, 3, 4, 6, and 12. It has lots of factors versus just 2. Because 3 only has the factors of 1, 3, 1 in itself. But prime factorization is writing a composite number as the product of prime numbers. So we'll learn how to write prime factorization. That would be something like saying 2 times 2 times 3 times 3 times 5. Greatest common factor is the largest factor that two or more numbers have in common. It may or may not contain variables. So let's go through some quiz. To check whether or not a number is prime. Now in my classroom, I have this giant poster that says primes to 10,000. If a number is on the poster, then it is prime. If it is not, if it is not on the poster itself, then it is not prime. You may not have access to a poster that large, nor do you want to memorize all those numbers. You will eventually memorize some of the numbers that are prime. But to check to see whether a number is prime, look for prime factors in order starting with 2. When you get to a prime whose square is greater than the original number, you can stop. For example, 23, check 2 and 3. 2 squared is 4. 3 squared is 9. That's still smaller than 23. 4 squared is 16. That's still smaller than 23. 5 squared is 25. 25 is greater than 23. And since 2 and 3 are not factors of 23, then 23 has to be prime. Remember, 4 is not a prime number, so I really don't have to worry about that one. So if we want to state whether or not a number is prime or composite, this is also where your divisibility rules would come in handy. If you know it's divisible by one of those numbers that I state, then you know it is not prime. So 46, I know it's composite because it has more than two factors, because it's an even number. The only even number that's prime is 2. So since it's an even number, I know it has to be divisible by 2. Okay. This has more than two factors. Now number 13. Let's see. I'm thinking of numbers that are prime factors. 2 is prime, 2 squared is 4. 3 is prime, 3 squared is 9. 5 is 5, 5 squared is 25. So we know it has to be less than 5. It's not divisible by 2 and 3, therefore it's got to be prime, because it's not divisible by any of those. So 13 is definitely prime. I knew that because I knew 13 was one of the prime numbers. Eventually, you will understand that it's also prime. All right, let's take a look at some other things. To write the prime factorization of a number, it is best to write out a factor tree. Always write factors in order from least to greatest, smallest to largest. Okay. To find the prime factorization of 273. Now, there's two ways to show a factor tree. You can show the actual factor tree, or you can do upside down division and kind of show a tree that way. All right, I'm thinking of 273. When some people look at that, they go, ooh, it's got to be prime, because I don't know what it's divisible by. Let's think about this. 7 and 2 is 9. 9 and 3 is 12. 12 is divisible by 3, so I know 273 is got to be divisible by 3. Right? 3 goes into 27 9 times, and 3 goes into itself once, so it's 3 times 91. 91 is divisible by 7. So 91 is 7 times 13. So the prime factorization then, I can do this, I can just circle my prime numbers. And those are all my prime numbers. My prime factorization of 273 is 3 times 7 times 13, because you have to write it in order. To write out the prime factorization, you're not just making a tree. Once you've made the tree, you have to tell me what the prime factorization is. Please don't list the numbers with commas. That doesn't work either because prime factorization is numbers that are multiplied together, right? A composite number as a product. A product means multiplication of prime numbers. Let's look at 225. And I'm going to do 225 slightly different. Instead of branching it out in the factor tree, I'm going to do the upside down division thing. I know 225 is divisible by 5. Okay? Happens to be 5, goes into 22 4 times. That's 5 times 45. I know 45 is divisible by 5. That's 5 times 9. I know 9 is divisible by 3. That's 3 times 3. So I'm now done because there are no remainders left. So I have my prime factorization from smallest to largest, 3 times 3 times 5 times 5. Or my preferred method, because you do know exponents, is 3 squared times 5 squared. You do have to show the multiplication. If you just say 3 comma 3 comma 5 comma 5 comma, you're going to come up wrong. Because you have to show it as a multiplication problem. Okay, 236, and I don't care if you do the tree or you do the upside down division, whichever one you're more comfortable with. I know this is divisible by 2 because it ends in an even number. So it's 2 times 118. I know that's divisible by 2. That happens to be 2 times 59. I know 59 is prime. So at this point I'm done. This is prime, and this is now prime. So I have 2 times 2 times 59, or 2 squared times 59. Always put them smallest to largest. You can write them with or without exponents, depending upon what the book tells you to do. If it specifically says write your answer using exponents, then you probably should use exponents. Now, we can use factor trees to help us find the prime factorization of numbers. I'm looking for the greatest common factor of 2 or more numbers. I'm looking for the largest number that will divide evenly into my numbers. So if I'm looking for 24 and 30, if I was going to find the greatest common factor of those, I'm simply going to do 24 here and 30 here. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So the prime factorization of 24, and I like to write prime factorization underneath here, is 2 times 2 times 2 times 3. For 30, it's 5 times 6, and 6 is 2 times 3. So for 30, my prime factorization is 2 times 3 times 5. And I like to line up my like terms if possible. Then the next thing I do, once I've done the prime factorization of each problem, I'm going to see if they have any numbers in common. And they have a set of 2's in common. They have a set of 3's in common. So the greatest common factor then, the GCF of these two numbers, happens to be 2 times 3, or 6. So the greatest common factor is 6. You always multiply them together. If I have variables, I'm going to do basically the same thing. If I have variables, I'm still going to break it down using prime numbers. So I'm going to break this down, 36. I'll break the number down first, and then I'll break the variables down second. 36 is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. So 36 is 2 times 2 times 3 times 3 times, okay, 36ab squared is 2 times 2 times 3 times 3. I have 1a times a, and I have 2 b's times b times b. Like I said, I was going to take care of the variables later in the problem. Okay, so I know the numbers are 2 times 2 times 3 times 3, and in the variables I have 1a and 2 b's. So I'm going to write down times a times b times b. 81, I know 81 is 9 times 9. 9 is 3 times 3, and this 9 is 3 times 3. So 81b is equal to 3 times 3 times 3 times 3 times b. What do they have in common? Okay, I have a pair of 3's here in common, I have a pair of 3's here in common, and I have a pair of b's in common. So the GCF then is 3 times 3 times b, which is 9b. The greatest common factor of 36ab squared and 81b is 9b. Let's look at a couple of more examples. The more examples we have, I think the better you'll understand. So I'm going to look at 15m squared n and 45m. Again, I'm going to do my prime factorization. So 15, 3 times 5, and 45, 5 times 9, and 9 is 3 times 3. So 15m squared n is 3 times 5 times m times m times n. And 45m is going to be 3 times 3 times 5 times m. Now I'm going to look and see what they have in common. I have a 3, I have a 5, I have an m. So the greatest common factor then is going to be 3 times 5 times m, which is 15m. That's the largest number and variable that will divide evenly into 15m squared n and 45m. Okay, let's look at this last example here. 36a to the third b and 4a squared b. Okay, so I'm going to take 36, which I know is 6 times 6, and 6 is 2 times 3, and this 6 is 2 times 3, and 4 is 2 times 2. So 36a to the third b is 2 times 2 times 3 times 3 times a times a times a times b. There we go. We have all the 2's, we have all the 3's, we have the a's and the b's. And then 4a squared b is 2 times 2 times a times times b. What do they have in common? I think I'll highlight them this time. They have 2 in common, and another 2 in common, and a in common, and another a in common. So the greatest common factor here, 2 times 2 times a times a. Whoops, I almost lost my b there. I just noticed I almost forgot my b. Times b. The greatest common factor is 2 times 2 times a times a times b. The greatest common factor is 4a squared b. So you did greatest common factor last year, you probably just didn't have variables with it. So the only thing you have to really pay attention to is now you might have variables in your greatest common factor problems, and that's okay. And we're going to learn later how we could use these to do even more things.